Have you ever looked up at the night sky and wondered about the stories those stars could tell? Well, today, we're diving into the most epic biography you can imagine, the life story of a single star. It's a journey that takes billions of years, from a fiery birth to a spectacular finale. And the wildest part, it's a story that leads directly to you and me. First things first, every story needs a setting. And this is ours, the Milky Way galaxy. You can think of it as a huge, sprawling city made of billions of stars. We're located way out in one of the spiral arms, about 27,000 light-years from that bright, bustling downtown center. The star we're following is just one citizen in this cosmic metropolis. So that's the big question, isn't it? How does it all work? How does a star go from just a cloud of gas to a shining beacon in the night sky? And what on earth happens when its light finally goes out? Let's get into it. Okay, before we zero in on our star, we really need to get our heads around the sheer scale of its stage. The universe is just unbelievably vast. So vast, in fact, that we need a whole new kind of ruler just to talk about it. Yeah, forget miles or kilometers. When we talk about space, we measure things in light years. That's the distance a beam of light, the fastest thing there is, can travel in one single year. And that's about 9.46 trillion kilometers. A number so big it almost doesn't feel real. So let's put that new ruler to use. How big is our star's hometown, the Milky Way? It is about 100,000 light-years across. To put that in perspective, if you could travel at the speed of light, it would still take you 100,000 years to go from one side to the other. And it's within this mind-boggling expanse that our story begins. All right, with that cosmic scale locked in, let's zoom way in. Because every star, including our very own sun, starts its life in a place that astronomers have beautifully named a stellar nursery. This diagram shows us exactly where it all kicks off, right here in what's called a nebula. Just picture a giant, cold cloud of gas and dust, mostly hydrogen and helium, just sort of drifting through space. This is it. This is the raw material, the cosmic clay that stars are made from. So how do you get from a simple cloud to an actual star? Well, it starts when a pocket of this gas gets cold and clumpy. Then, the most powerful force in the cosmos takes over, gravity. It starts pulling all that gas and dust inward, crushing it down until it forms a massive dark ball we call a protostar. It's not shining yet. Think of it as a star that's still loading. Now, that protostar keeps getting smaller and hotter for about 1 million years until, bam, the light switch is finally flipped. This is the moment a star is truly born. It's now entering the longest, most stable phase of its entire life. I love how the source material describes a star. It's basically a hydrogen nuclear energy furnace so big that it holds together by itself. What's happening is that deep in its core, the temperature and pressure are so intense that hydrogen atoms start smashing into each other and fusing to create helium. This is nuclear fusion. This whole fusion process releases a tremendous amount of energy, which we see as heat and light. And this is the main sequence phase. It's this incredible balancing act between gravity trying to crush the star inwards and all that fusion energy pushing outwards. Our sun is right in the middle of this phase now, and it's got about another 5 billion years left on the clock. But, no fuel tank can last forever. Eventually, the star starts to burn through all the hydrogen in its core. And this is where the story takes a really dramatic turn. This is the beginning of the end. The moment that hydrogen fuel is gone, that beautiful balance between gravity and fusion is broken. The core starts to shrink, but the outer layers of the star do the opposite. They swell up massively, cooling down and turning a reddish color. It becomes a red giant. And yeah, this is our sun's fate too. One day it'll puff up so big it will completely swallow Mercury, Venus, and possibly even Earth. So after the red giant phase, our star reaches a fork in the road. And what happens next, its whole grand finale, depends on one single thing: its mass. How big was it to begin with? As you can see, stars like our sun, they take a quieter path. They sort of fade away. But the really massive stars, they go out with an unbelievable bang. So let's follow that more dramatic path for a minute. Because for the biggest stars in the universe, their death isn't just an ending. It's one of the most powerful and strangely creative events in the entire cosmos. After its time as a red giant, the core of a massive star just keeps collapsing under its own insane gravity. It gets smaller and smaller and denser until it physically cannot collapse any further. And at that point, you get a catastrophic rebound. The outer layers of the star are violently blasted out into space. We call this a supernova. And the source describes it perfectly. It explodes with a brilliant flash like a nuclear bomb. For a brief moment, a single supernova can outshine its entire home galaxy of billions of stars. So what's left behind after this cosmic fireworks show? Well, the ghost of the star that remains depends on the mass of that collapsed core. If the core is up to about 3 times the mass of our sun, it gets crushed down into a neutron star. This thing is so unbelievably dense that a single teaspoon of it would weigh billions of tons. But if the core is even more massive, gravity wins the fight. It wins completely. It collapses forever into a single point, creating a black hole, an object with gravity so powerful that nothing, not even light itself, can escape. And this is where our story brings us right back to the beginning, full circle. If you look at this diagram again, you can see the cycle. That spectacular supernova explosion doesn't just destroy, it creates. All the heavy elements that were forged inside the star, we're talking carbon, oxygen, iron, are blasted across space. This stardust enriches those cold nebulas, becoming the raw material for the next generation of stars, planets, and eventually us. So when we look up at the night sky, we're not just seeing lights. We're seeing the past, the present, and the future of creation all at once. The iron in your blood, the calcium in your bones. Every bit of it was forged in the heart of a star that lived and died long before Earth even existed. Which really leaves us with a final thought. Is a star's death really an end, or is it just another part of an endless cosmic beginning?